So this is the first Casalegno lectures. So as usual, you start with the lecture and then we have the discussion.
Good, thank you. So in sketching the so-called projection strategy that I talked about mainly last time, I emphasized the notion of causal independence and giving the examples, for example, Goodman's way of thinking about dispositional properties that we'll talk more about next time, and in particular the attempt to sort of explain the notion of chance in the way I was suggesting. Causal independence played a central role. It also plays, I think it's intuitively a more robust, simpler relation than causation itself. Causation is complicated, exactly, and a lot of controversy about even given notions of causal independence, although they obviously constrain the notion of causation, they don't yield a definition of it. So it's, I think, a more basic notion. It's also the role, the role in epistemological reasoning of notions of causal independence. For example, in the whole idea of random samples and other sort of more specific kind of inductive methods that play a role in both common sense and scientific reasoning involve the notion of causal independence. And also, finally, the notion of causal independence is intuitively a closeness or yields a closeness relation or similarity relation of the kind that's relevant to the interpretation of counterfactuals. It doesn't yield a reductive account of one, but it does connect up with intuitions about closeness of possible worlds. So the main idea, at least as I thought of it, always thought of it, of the idea that you pick the closest possible world or a closest possible world, is the idea that you make in constructing a conception of the counterfactual world, you leave everything the same except what's needed to change to make the antecedent true. So if you think in this sort of intuitively, not as sort of selecting a world so much as constructing one, although that's not something one doesn't want to take too seriously, but constructing a conception of a world, you want to leave everything the same, tweak the world to make the antecedent true, but leave everything that you don't need to change the way it is. But what does it mean to be something you need to change? That's the whole problem, because you always are changing some things and leaving other things the same, no matter how you do it. So the idea of causal independence plays a role. Obviously, if something is independent of the antecedent, plays no role in the sort of causal chains involved in the events that one is changing counterfactually, then one leaves everything the same that isn't necessary to do that in the sort of effects of the antecedent. Now again, there's no explanation, but it's just a connection of intuitions with some other things. And in general, the strategy, the non-reductive strategy, is not to reduce the notion to something more basic, but maybe in some ways the other way around. That is, if we find a central notion, which itself is one of the problematic ones, if we can explain a lot in terms of it, a lot both of the function of counterfactual reasoning and so on, and use it to help analyze other notions, then we clarify a concept by using it to clarify or to connect with other concepts. So that's the general kind of strategy. More methodologically, the strategy as contrasted with a reductive strategy is going to be piecemeal. So the best way to try to, one good way to try to clarify the difficult concepts we're interested in is to find specific models which concern a particular kind of application. They normally, if you want to be precise, as we do, but there's always trade-offs in being precise, so you use models that are highly artificial and idealized in some cases, but ones that are concern a specific kind of issue, and then see what you can do in explaining how counterfactuals work in that limited artificial or idealized context. And we'll see that when you do that, it raises some problems of interest and also helps to clarify what's going on in a more general case, or at least that's the hope. So causal independence plays a role, I emphasize, in epistemic reasoning, but it also plays a central role in practical reasoning, and that's going to be the main focus, and that's the kind of models I want to talk about today is, again, artificial models of decision-making as developed by theorists who aren't focused in particular on counterfactuals. They're focused on the task of Bayesian decision-making. But there's lots of causal and counterfactual information presupposed implicitly in the characterization of in particular of games, but more generally of decisions. So a game, in the game theoretic sense of a game, is a sequence of decision problems, and the definition of a game imposes a lot of causal structure. It's a sequence, so we have a process, an evolving process in the course of the play of a game with causal influences and causal independence involved in characterizing the flow of information and the flow of decision-making in the course of such a complex of decision problems. So I want to look today, talk first of all by just some exposition and contrast of some alternative versions of decision theory which contrast with each other in virtue of the role they give to causal structure in the characterization of what's involved in rational decision making. So we'll look first at different versions of so-called causal decision theory versus evidential decision theory briefly, and then look at the third framework for decision theory which is connected, namely game theory, and think of game theory as a kind of application of causal decision theory. In the end, what I want to do is raise a puzzle, a problem about the relationship between determinism and the kinds of structures that are developed in the case of modeling decision making. A tension between determinism and these structures, which are also involved in the concept of chance. We'll look at the relationship between, the familiar philosophical problem of the conflict of determinism and free will is the most prominent focus of this kind of problem, but there's a more general problem about the relationship between counterfactuals and determinism, which I think it helps to look at to look at the relationship between the more general problem and the more specific problems about decision making and free action. Okay, so to jump in, by first just looking at the basic ideas of Bayesian decision theory and see how causal structure is involved from the start, really, of the formulations of these theories. They don't talk about causation or causal independence, but it's implicit in the development of the theory. So start off with the basic idea of all versions of Bayesian decision theory is when faced with a decision problem, this is the start of the handout here, the outcome will depend on two things, two interacting things. First, what are the alternative available actions to be chosen? So basically, you can think of what the theory is telling you is what do we need to know to have a decision problem? And what are the resources that the agent needs, the epistemic and other resources, mental resources, in order to, for it to make sense to assess the agent's action as a rational action, as the right thing, rational thing to do, relative to something, relative to what? So the decision theory is going to spell out what we need to assume in order to, what assumptions we need to make in order to have a context in which we can specify what's rational. Okay, so in a realistic situation, it's going to be difficult to say, well, what are my options? What can I do in a particular situation? But in giving a kind of artificial model, you say the first thing to do is to get an understanding of what you regard your options to be. And the theory will assume that you know what your options are, what you can do, what's available to you to do. The outcome of your action, the outcome of your choice, which of the alternatives you choose, the outcome will depend not just on what you choose, but also on facts in the world, which may include unknown facts about the world on which the outcome depends. So if you choose to accept a bet on a certain flip of a coin, then you know that the outcome will be either you win and wind up richer than you were before making the bet, or you lose, winding up poorer. So you accept the bet by paying down the amount you need, and then you either win or you lose. So the outcome, the good or the bad outcome, depends on a fact over which you have no control. That is, you have control over whether to bet or not, but you don't have control about whether the coin lands heads or tails. Maybe you have control over whether the coin will be flipped, because it won't be flipped unless you bet. But once you choose the bet, the outcome of the coin is not affected by that. Okay, so that's the very rough intuitive idea, and then you say, okay, so what we need is a characterization of two things. What are the available options, and what are the possible states of the world, states which characterize the relevant facts about which you may be ignorant. Since you may be ignorant of them, what you need in addition, since obviously it doesn't matter just, whether you win or lose depends partly on what you think about the coin, that is what your beliefs are about the coin. So you have partial beliefs, probability beliefs, subjective credences or subjective probabilities in the relevant facts. So you specify a probability function which represents, in defining the decision problem, which represents your ignorance, your degrees of belief about the alternative states of the world on which your outcome, the outcome of your choice, will depend. Okay, so if there are, say, 3 alternative actions and 4 alternative states, then you can take each of the pairs consisting of an action and a state and ask, what's the outcome or the consequence of that pair? If you do choose action A in situation S, what do you get? What happens? Or what value do you put on that? So you've got to specify the values for the consequences of your possible consequences of your action, probabilities on the states of the world, that where states are understood as causally independent, in particular situations about the world which are causally independent of your action choice. So you have a kind of two-dimensional matrix with actions on one dimension and states on the other, with the utility values of the consequences written in the boxes in the matrix. So then how do you decide? Because the action does well, sometimes not well others, and you say, take the, what you should choose is the action that gives you the best expected utility, expected value, expected desirability, whatever you want to call it, where expectation is understood in a usual way, as in statistics, as a weighted average. So you have a weighted average of the value of an action will be a weighted average of the values of the outcomes weighted by the probability or credence in the state. So if you think the coin is heavily biased, or maybe 2/3, 1/3 biased for heads, then your degree of belief will be 2/3 that it will land heads and 1/3 that it will land tails. So you're going to bet on heads if you bet, and your action would depend on what the odds are. That is, what do you win if it's heads, and what do you lose if it's tails, and you would just take the weighted average. So that's the standard general characterization, and I'm describing this in terms of states and actions using the terminology introduced by Leonard Savage, whose version of Bayesian decision theory is the most sort of influential among statisticians who are applying these Bayesian techniques to statistical reasoning. So central, I mean, the thing I want to emphasize here is central to this way of thinking about decision theory is a notion of causal independence, that one finds features of the world. Some features of the world will be affected by your actions, others will be unaffected, and states will be the state of the world that's unaffected by your action. Okay, so that's, but when Savage spelled out this version of decision theory, it was a very, it was not it was designed partly to motivate certain representation theorems, but the formalism was intuitively quite artificial in certain ways. In particular, the notion of an act or an action was simply defined. We had the primitive notions were notion of consequence with the outcome, possible outcomes. What do you get in the end, on the one hand, and actions, or rather states, on the other. So states were primitive, consequences were primitive. Acts were just functions from states to consequences. So it's clear that if you think of it in the way I described it, as sort of a matrix, you can say, well, if you start with the consequence and the state, then each act will determine a function from states to consequences, because you just look at each of the states and ask what are the consequences for that state. But of course, acts are not some kind of artificial function. What they are is things you do. So it's a more sort of elegant and uniform formulation would treat actions, states, and consequences all as facts about the world. So it's a fact about the world that you choose one action rather than another. It's a fact about the world that it's in this state or that state, and the two things together determine a fact about what the consequences are of your action. So Richard Jeffrey was not happy with not just the inelegance of the savage framework, but also with the role played by causal notions, being an empiricist who is skeptical of causal concepts. So his formulation of decision theory tried to avoid any reference to causal notions. And it also provided you with a kind of uniform framework. So you start for Jeffrey's formulation of decision theory, you start with a state space, which is the same as a set of possible worlds. I'm not necessarily sort of complete possible worlds, but just sort of a partition of the possible states of the world into all the relevantly different ways things could go. So in terms of the sort of model here, so you think of this rectangle representing the state space, and each action should be thought of as a proposition, the proposition which is true in worlds in which you choose that action. Okay, and then the savage kind of notion of states cuts across, and the consequences are, so you say, you put in a number here, a utility value, and so on, and then and then you have a probability assignment here in Savage's theory. In Jeffrey's version of the theory, forget some specific identified partition of states, and just think of a state space divided into actions. Then take any proposition, so draw one without the states here, we have take any proposition represented by some subset of the space, and we can say, what is the value of this proposition? So take any proposition at all, including an action proposition or something that has some causal properties or whatever. Take any proposition. The Bayesian decision theory will be defined in Jeffrey's theory independently of any assumptions about the relationship between these propositions and this other one. So, but the same principle of expected value is applied. So you say each subset of the space of possibilities has a value, a utility value. So there's no sort of one thing that's the consequences. There are any proposition, you can say, what is the value of that proposition? Now, the value of a proposition depends entirely on how it is, intuitively, on how it is realized. So if I say, consider the proposition that that we go on a picnic tomorrow or something like that, and I say, well, If it rains, that'll be a big mistake. So it'll have a low value in the context where it rains, and it'll have a higher value in the context where it doesn't. So in general, take any proposition, quite independently of any actions or anything else, and say the basic rule is that the value of this proposition is a weighted average of the value of its subsets. So, we don't start with sort of values assigned to cells, primitive cells or worlds or anything like that. We start simply with the constraint in your value theory that, that the value of a proposition is a function of the ways it could be realized. So that's a global constraint on utility. But in the particular case where we're looking at this proposition and these values, then the value of this proposition will be a weighted average of these, weighted by the probability of that. So you can see the Savage theory is really a special case of Jeffrey's a kind of a generalization of it, but the point is that you don't need to make any causal assumptions. There's no particular partition of the space into states that plays a special role. So causal independence is playing no role in Jeffrey's theory. Okay, so in this context, we have a kind of inelegant but interesting causally loaded version of decision theory, a much more streamlined theory formally, but also leaching out the causal assumptions in the theory from Jeffrey. And this, and it's interesting that philosophy, I mean, it's sociologically interesting that the philosophers were often brought up on Jeffrey after he wrote his Logic of Decision, and that was what they thought of as basic causal decision theory, or basic version of Bayesian decision theory. Whereas statisticians didn't pay a lot of attention to Jeffrey. They were brought up on the Savage kind of way of thinking, or on some alternatives to it. But then David Lewis comes along and formulates what really, in the end, is a version of Savage's theory with respect to the significance given to causal notions, but formulated in a kind of framework which is more like Jeffrey's framework. And as Lewis and other sort of developers and defenders of so-called causal decision theory that came later, Lewis thought of Jeffrey's theory as a value theory, not a decision theory. So if you want to say, you can reasonably say, for any proposition that you might learn, say, how good is the news for you that that proposition is true? So suppose you just learned that you missed your airplane, right? Is that good news or bad news? Well, bad news. But there's a piece of that proposition, a subset of that proposition, which is good news, namely the one where the plane crashes. So there's a possible world where you miss the plane and it crashes, in which case you put a high value on that. Cases where everything goes normally and you would have reached home earlier and less inconveniently is good news. So in general, you can ask simply about the value of a proposition that might be realized in alternative ways and say, well, whether it's good news or bad news that that proposition, if you were to learn that that proposition is true, would be a matter of variation from case to case, but the overall thing is say, well, I'm almost certain that the bad outcome won't happen because, you know, we take for granted that it's extremely unlikely that the plane's going to crash. That's why we take them. So the probabilities of the alternative ways which the proposition can be realized are themselves playing a central role in evaluating the proposition simply as a fact, as a possible fact. So Jeffrey's value theory is defined quite generally, not just for acts, but for anything. But given that acts themselves, the actions that are available to you, are propositions, or represented as propositions, the proposition that you perform that action, that you choose that action. So the value theory tells you what is the value of an action. What if you learned, maybe you forgot what you did, but you learned that you chose action A1. And then you can ask, is that good news or bad news? Saying you know everything that you knew at the time you made the choice. Jeffrey's decision theory says choose your actions by choosing the option that would be the best news if you learned it, that you did it. So the evaluation of passive propositions, the assessment of the value of a proposition, is the same as whether the proposition is an action or not. So what Lewis does is say, I want to buy Jeffrey's value theory, but reject his decision theory, saying don't choose an action as the one that would be the best news, but choose the action that would tend to cause, or would, if you were to choose it, it would bring about a situation that's better than what would be brought about according to your assessment of what would happen. So if you just put the contrast starkly, one of the ways to put it is to say the expected utility of an action, say there are two, we divide the possibilities into two parts, S or not S, and we say it's the value of A and S times the credence, the probability of the part of A which is in no. Plus the probability of not S times the value of A and not S. Okay, so take a weighted average relative to S, where S is any way of dividing the thing at all. Lewis's formulation doesn't appeal in some versions to a particular notion of state, rather says instead of the probability, the conditional probability, which is an epistemic notion, we should take it to be, and this is evidential, just one way of understanding it, the probability for the agent of the counterfactual times the probability of okay, so the contrast between Lewis's theory or other versions of it, is for Jeffrey, we take a purely evidential relation, and for Lewis, we take a causal, a counterfactual dependence relation. If it turned out that you know that you're dealing with savage-like states which you know to be causally independent, then these two things will be the same. But in general, they will be possibly different. Okay, so which version is right? And this is where the causal decision theory in particular was designed with a certain particular, very famous decision problem in mind. And it's interesting, the decision problem was formulated, which is Newcomb's problem, formulated by Robert Nozick, who was very much get Jeffrey's theory to be the right theory, or not the right theory, but the sort of given or standard theory of decision, Bayesian decision theory. So Robert Nozick posed the problem as one that suggested that, at least on a certain way of thinking, Jeffrey's theory yielded the wrong conclusion. Okay, so let me sketch the Newcomb problem. Most people will probably be familiar with it. It's been around for a long time. And it's something that created controversy because, first of all, the intuitions about the example vary from case to case, and also exactly what the theoretical consequences are is something you can debate. Okay, so but just quickly describe the problem, and then you can think about what you think about this. You're presented with two boxes, an opaque box that contains either $1 million or nothing, and a transparent box that contains, as you can see, 1,000 euros. What did I say? 1 million euros, right, and 1,000 euros. Your options are, first, take just one box, just the opaque box. Forego taking the transparent box. That's one option. Your second option available to you is to take them both, take the contents of both. The money is already in the opaque box or not. So your choice, and this is the causal assumption, your choice has no causal effect on the amount of money in the box. The amount of money in the box is causally independent of your choice. So if you think in Savage's terms, it's a state of the world, that the money is there or it's not. And you have to think, what are your degrees of belief about that state of the world if you're thinking in Savage's way or in Lewis's way? So then the final part of the story is, how is it determined whether the box contains $1 million or not? And the answer is a predictor who is actually very good, very reliable, predicted what choice you would make. And on the basis of her prediction, she put $1 million in the box if she chose that you would pick just one, and she put nothing in the box if she chose that you would, if she predicted that you would choose both. Now the story about the predictor is not someone with magical powers. It's not someone who can see into the future. So there's no idea of causal influence of the future on the past. It's rather that there have been extensive psychological research done on this problem, and it's turned out to be very highly correlated with a certain score on a personality test or a cognitive test of some kind, which you have taken, although you didn't know anything about the problem at the time you took it. So the predictor based her prediction on the results of your test. But you have no idea initially what test result was, or even what the test was important in it, and so on. All you know is the problem you've just been given, and the evidence which everybody is given who has this problem, has faced this problem in the evidential base, knowing that you, knowing what the predictor has been very reliable based on this kind of evidence. So the argument is that if you go with Jeffrey's decision theory, then you say that conditional on learning, on the choice of picking both boxes, that gives you high evidence, a great evidence that you are, if you choose one box, that you're the one box type, and so probably the predictor put the money in there. So your conditional probability on the choose just one choice is high that the money's there, whereas your conditional probability on the hypothesis that you make the both choice is low. So if you do the weighted average this way, then you get the choice pick both boxes having much greater expected value, assuming that you like money. And that's really all that matters in this case. On the other hand, if you go with the causal decision theory version, then you get a contrast between what you would think if you learned. Suppose you made your choice and you woke up and you forgot what you choose. And you say, what do I hope I chose? And you say, well, I hope I chose just one box because then I probably will get the money. But if you are actually faced with a choice, according to the causal decision theorists, you should go with the choice of both boxes, because the counterfactual, since it's counterfactually independent, whether the money's there in your choice, you can say, suppose I'm the one box type, then if I chose two boxes, then I will choose, maybe, I'll probably choose one box. But if I were to choose two boxes, I would do better. So you have a dominance argument because of the causal independence of the assumption. So on the assumption that the money's already there, if the money is there, then I do better to take both. If the money's not there, I also do better to take both because I got 1,000 rather than 0. So you have a kind of dominance argument that we don't have to worry about whether the money's there in terms of assessing the rationality of the choice. Okay, so, people, you can sort of give various thought experiments and arguments, making it plausible that the choice should be one way or another. One could say, suppose you're making the choice and I'm sitting here, I'm your advisor, and the box is transparent, both boxes are transparent in this direction, but opaque, one of them in your direction, so you can't see whether the money's there, but I can. But I'm not allowed to tell you. But I am allowed to give you advice. Okay, so what advice am I going to give you? I look in there, I see the money, I say, take both. I look in there and I see no money, I say, take both. So you don't need an advisor. You already know you should take both, because that's what a person who has your interests at heart, who knows more than you do, would tell you. So, there's the argument of that kind in defense. Other arguments that notice that the one boxers all get rich and the two boxers don't, so wouldn't it be better to be one of the rich people? And the two boxer says, yeah, it'd be nice, but I happen not to be, that happens not to be an option open to me because I'm not that type. Okay, so that's the contrast. Now, when you can think about, I'm not going to go, I want to use the Newcomb problem mainly just to illustrate the contrast between the two views. Now, a game even though game theory developed somewhat independently of Bayesian decision theory, it still used the notion of expected value, although using objective probabilities the way it was thought about. So a game is a sequence of interacting decision problems. And in defining a game, unlike defining a Bayesian decision problem, you specify utility values for the outcomes of the game, but you don't specify for the different players, but you don't specify the probability values. So the idea is supposed to be what you know about things you don't control are what you know is what the other person's values are. So you know the other person is going to act rationally. So if you figure out what's the rational thing for the other person to do, then you can predict that the person will do that. Or if you think it's probably probably the person's rational choice is this rather than that, so probably they'll do this rather than that. So you base your decision on, again, what corresponds to states of the world are other people's choices. What corresponds to your choices are the options available to you. So the specification of the game specifies options for the different players and doesn't specify what you believe about the other players in a quantitative way. It just specifies that you believe they're rational. So best way to think of game theory, I think, although it wasn't originally thought of in this way, is as a partial specification of a sequence of decision problems. You can define a model for a game which fills in the rest of what you need to know to determine what's rational to do, namely beliefs or credences that you have in the other person's actions. Then you could add a general constraint on the theory, but let's suppose that you know, or that it's common knowledge, or other assumptions you can make, that all the players act rationally. Then you can say, what kind of model of a game what would people do? What are the constraints on what people would do in some model which meets that constraint? So that's the sort of Bayesian way of thinking about the application of game theory. Now, a game generally will be defined by a tree structure where you label the tree by the player. So player A gets to choose left or right, player B gets to choose left or right, and then player A gets to choose again. And then in all the possible final outcomes, you put in a utility value for each player. And then you think, what will the player do given that they're rational? And you say, well, it's clear enough what A will do if he reaches that point, but maybe he won't reach that point because maybe B will choose here. So in order for A to figure out how to assess the difference between the best value here and compare it with the best value here, has to make a prediction about what B will do. And that prediction can be based on what A knows about what B's values are. So we have to think, what will B get if this is the outcome versus what will B get if one of these is the outcome? And say, well, player B's choice, given that player B is rational, will depend on that utility. So player A uses B's values to predict, to make an epistemic commitment, and uses her own values to predict, to choose which of the options, and so the interaction of those kinds of things. Now, so you can add some further complications which involve, in order to get more interesting games than the pure perfect information games, which involve a further consideration of causal independence. I mean, the point is here we already have in the tree structure some assumptions about causal independence. Nothing B can do will affect what A did first, but what B can do will affect what A does next because A won't have a choice. Or even if A did have a choice, a further choice, B can affect A's action by choosing something, because A will choose one thing one way if he's here and another way if he's there. So you have causal structure built in to the story. Now you can add an assumption that A has to make her last choice, should she get there, in ignorance of what B did. So this is an assumption of causal independence, is to say we can add a constraint, a so-called information set, which says A's choice is counterfactually independent of B's choice. So A doesn't have the option of choosing this on this possibility and that one on that. These are be linked. So this is a single choice point. A can either choose to go left, whichever place he is, or to go right. And that's an assumption of causal independence. So the definition of a game builds a lot of causal structure, and that causal structure plays a role in determining what the options, what options are available to the player, and what the consequences of the actions, the way in which they depend on each other. So after defining games in this extensive way, but with tree structures, von Neumann and Morgenstern, when they first invented game theory and developed it in the 1940s, suggested that we can give a more abstract formulation of the theory, the so-called normal or strategic form of the game. And I'm going to talk next time some about strategies. A game in strategic form is something that looks more like one of these matrices. So we might have A will have 3 strategies, say, and B will have 4 strategies, although that's not this game. In this game, A has either the strategy of go left first and right second and so on, or whatever, and B has the strategy, just one choice, so in the simple game. But in a game with many moves, your strategy will be a choice at each possible point that might arise. So you can say, and this is the way von Neumann and Morgenstern justified the idea that the strategic form represents all you need to know to determine what's rational. They say, suppose you're going to play one of these games and you know perfectly well what the tree structure is. But suppose instead of playing the game in real time, we say that we have a referee, and you are to turn in a strategy to the referee saying what you would do in each of the possible circumstances that might arise. So what would you do if you reach this choice point, and what would you do if you reach that choice point, and so on. It's for every choice point that you might face, you choose one of the options, and that's a strategy. So a strategy is a complete specification, not only of what you will do, but everything you would do if the occasion were to arise. So again, a counterfactual built into the characterization. So the idea is that in an ideal situation, choosing a strategy is rational if and only if making the choices dictated by the strategy would be rational in each situation that were to arise. So we could play the game in this boring form where you turn in your strategy first, and then the referee plays out and says, here's the outcome. Right? So here the idea is, if you represent it in this matrix form, we have a very clear representation of all the complex causal interaction is sort of reduced to the dispositions that the player has at the start of the game. And so the idea is that the game would unfold by perfectly rational players in exactly the way that will yield a decision made in this form, strategy choice form. So the idea is that here, and to put this into the more Lewis and Savage way of thinking about decision theory, for Alice, these are her options, and these are her dependency hypotheses or states in Savage's sense. These are the facts that Alice can't control, namely what Bert's strategies are. And similarly, Bert's actions treat these as states. So the sort of state-action contrast in the classic versions of decision theory are reflected in the game. So again, causal independence, and and also the idea that the world unfolds as a result of the dispositional states that it has at an earlier stage. So this sort of dynamic pattern is reflected in a static version of the game. Now, there's a lot of controversy, and in particular, enormous idealization needs to be made to get the equivalence of the normal form and the strategic form. In fact, in playing out in real time, you don't make hypothetical decisions about what you would do in situations that aren't going to arise anyway. You'll make them as you go. It's much more efficient. But the extreme idealization of the theory just sort of abstracts away from all that. So in particular, if you were to think of chess as a game, and with a definition, there are each player has a certain number of complete strategies, and the number of strategies that each player has is greater than the number of atoms in the universe, right? So if you weren't making sort of the assumption of logical omniscience, perfect computational power, nobody could ever play a game in strategic form if the game has any complexity at all. In fact, from an ideal point of view, chess is really not that different from tic-tac-toe. Because tic-tac-toe, you really could spell it out. The only difference is chess is more complicated. And so it's harder to figure out what the ideal strategy is. And in fact, it's even harder to figure out, theoretically, who has the ideal strategy. So it could be that white could always win in chess if he played ideally. And it could be that black could always win, or it could be that it will always be a draw, probably the last. But there's some games where if you go first, you lose, and if you play ideally, and the other player does, and others where if you go first, you get to win. So the idealization is ridiculous in some ways, but still the games we look at in order to reveal certain features of strategic reasoning are often simple ones where the idealization is not so extreme, and one can learn something about strategic reasoning generally from those kinds of games. Okay. All of these ways of thinking about decision theory and all the ways in which causal structure is built in involve this kind of tree structure, branching structure of some kind. And this applies to chance as well, because you can think of chance, a chance model, as an evolving sequence, say, of events where chance changes as we go. A chance model as a kind of special case of a game, a degenerate case of a game where there are no players other than nature. But you have the same branching structure with a chance here and then a chance there and so on. Probabilities assigned to the branches in the tree. So the branching structure, together with some further assumptions about causal independence, play a central role in the characterization. But the question, that sort of general problem I wanted to raise about determinism is, how do we fit this sort of branching idea, this idea that there are alternatives at various points in the course of a sequence of events, with determinism? David Lewis asks us to consider, and this is a general problem, not about games, but about, or decisions, but about the relationship between counterfactuals and determinism. David Lewis asks us to consider, and this is the last page of the handout, a counterfactual that supposes that some ordinary actual event did not happen. There's an antecedent, counterfactual antecedent about an event, any event. Suppose I had not blinked at a particular time when I in fact did blink. Determinism seems to imply that the counterfactual world which I choose, or the counterfactual worlds that I choose, the closest ones in which I blink, have to be either ones where the history, the events in the past were different all the way back in some respects. Because if they ever were the same at some point, even no matter how far back, then determinism would say that I blink, would entail that I blink, assuming the laws are true. So either the world was different all the way back through time. If I had blinked, things would have been different a million years ago. Or an event is, a law of nature is violated in the actual world. If you then think of this in terms of action, you think, when I'm choosing whether to do A or B, do I have the option of falsifying a law of nature? Or do I have the option of altering the past? Because this is true that if I were to make the alternative choice from what I'm going to make, then the past would have been different, or a law would have been broken. Both of them seem grossly implausible. So there's a question, there's a tension between a kind of law-based theory of the causal structure of the world, and which in some ways one think that determinism is sort of, you can't change anything without changing everything. Right? There's no sort of ways to divide things up in the way in which counterfactuals seem to require that you do. And the problem is particularly acute when we're talking about what we regard as free human action. And this is a real puzzle, I think, and I don't know exactly what the general response to it should be, but I do want to suggest that at least intuitively, the distinction concerning causal independence it is not incompatible with determinism. So I use this little example to illustrate this. Alice accidentally dropped a flower pot out of the window, third floor window, in exactly the moment when Bert was passing below, so it hit him on the head. Few people walk by this street, so it was a rare event that there was someone there. Rarely does Alice drop a flower pot. I mean, she just happened to this one time. So it was a remarkable coincidence that Bert just happened to be there at the wrong time. It seems intuitively clear, if one just thinks intuitively about counterfactuals, that if Bert had left on his walk just a few minutes later, then the flower pot would not have landed on his head. Because the way we've told the story, Alice's event was independent of Bert's, causally independent. That's to suggest that the causal chain leading to Alice's dropping the pot would still have been true in the counterfactual world, which we define as the one that would be if Bert had left on his walk a little earlier. Now, this assumption about the causal chains is wholly compatible with determinism, because what determinism says is the whole history of the world, if it were the same at some earlier time, then that means Bert's causal chain and the causal chain leading to Bert's being there and the causal chain leading to Alice dropping the pot would each be determined, even though completely independently, by the same global state of the world. But that's compatible with saying that nevertheless the chains are different. So that it seems the idea of holding certain things fixed and not others is perfectly compatible with determinism. But if we push further and ask the following question about the relevant counterfactuals world in which Bert left on his walk a few minutes earlier, would the chain of causes leading to Bert leaving when he did have been different from what it was all the way back through time, or would Bert's leaving for his walk a little earlier have been caused by a miracle, been brought about by a violation of a law of nature? Something goes on in his brain that slows him down a little bit and he leaves a little later. Which would it have been? And one wants to say, well, that question just doesn't arise, right? In terms of what we care about is the causal independence of these two chains. Nevertheless, one might think on a general account of counterfactuals that uses these kind of modal resources, we're forced to answer that question. And that's really the puzzle. What one would like is a way of saying that the problem just doesn't arise. Now, Lewis distinguished what he called backtracking counterfactuals from the standard kind. So a backtracking counterfactual asks, if something had happened that didn't happen, why would it have happened? So we look backwards at the course of events that leads to the event rather than forward to what the consequences of the event will be. And the backtracking counterfactual yields a different conclusion that's not compatible with what's led by the other one. So, about Bert, we could say, well, if he had left a little earlier, it probably would have been because the phone rang, or whatever. I mean, you could say, or because some other distracting event took place. But we don't assume, when we're looking forward to what would have happened at the occasion, we don't look to this causal story. If we do look to the backtracking way and the forward-looking way with actions, we get something quite different. So if I choose both boxes, one can ask, why did I choose both boxes? And I say, because I believe that if I had chosen just one, I would have gotten less money than I am going to get, even though I don't know how much money it is. It's probably nothing, 1,000 rather than nothing. But I know that I would have gotten more money than I would get. So therefore, I chose both boxes because it would have been irrational for me to choose just one. But if you ask, if I had chosen one box, why would I have chosen it? And I say, well, I would have chosen it because my values and my reasoning would have been different than it is. That I would have been a different kind of person than I am. Or more, in terms of more realistic kinds of decision problems, I could say, two questions I can ask. I can say, if I made a choice, I decided to take the job rather than not to take the job. And you say, if you had decided not to take the job, why would you have decided it? And I say, well, I would have had slightly different priorities than the one I have, and one I in fact have. I would have different values. It still would have been rational, but it would have been rational relative to a different set of beliefs and desires. So if you look in the backtracking way, you're saying the miracle, if there's a miracle, is not somehow I choose against my beliefs, but rather my values, but rather I would have had different values. But if you ask why, in the forward-looking way, why did you choose this? I say, because if I had chosen otherwise, I would have acted irrationally. And that's when you ask about the Sly Pete case. Why did Pete fold? Because he knew it would have been irrational for him, because he would have lost if he called and lost more money. So the backtracking way doesn't help us get out of the puzzle about determinism. So that puzzle remains, and of course it's a familiar puzzle anyway, but I think it's some illumination to thinking in this broader context of a puzzle about counterfactual reasoning and not just a puzzle about decision. There's also an issue, I mean, of course, one can try to defend a compatibilist solution to the problem of free action, but in doing so, one has to sort of address these broader issues. There's also a compatibilism alternative with respect to chance. So that some people think real chance, depends on fundamental indeterminacy, quantum mechanics or something. But of course, the application of chance in science is heavily involved long before quantum mechanics is thought of in terms of statistical mechanics and so on. So determinism seems to be compatible with the scientific application of objective probability, and explaining how that happens is part of the same pattern of problem. Okay, so I'm sorry to go away on so long, but next time we'll look at the general question of dispositional properties, and then look back at the game situation, the decision situation, and look at strategies as examples of a certain kind of disposition, and see if we can throw some light on these questions of the relationship between dispositional properties on the one hand and decision intentions and plans on the other hand. So thanks.
Thank you. So, other questions? Maybe I start with a question and then I give them time to think about their own question. Let's consider again the Newcomb's problem. Because when I consider this kind of example, I'm never sure about what to think about it. On the one side, I agree with you that what seems to be rational is to take the two boxes because we believe that counterfactually, whatever I do now is not determined by everything which happened before, is causally independent by what I'm doing now. But when we think about the example and the frequencies of the prediction of the person together with the results, we start to doubt that there should be some causal connection. Maybe a backward connection. Could there be a backwards causation? For example, or there is a forward connection, maybe the predictor causes somehow what I'm going to do, let's say, or what I'm going to do may backwards cause what the predictor did.
Right, yeah.
So I was thinking, as the example is so complicated, it seems to me that it allows for different counterfactual explanations of it. And I wanted you to...
Good, yes. So it's true that one, in reaching the conclusion about the causal independence, one is not relying on some theoretical account of reductive or otherwise of the counterfactual. One is relying heavily on the intuitive judgments about causal independence. Now, the story is sufficiently bizarre in some respects that one can raise doubts on the intuitive level about the causal structure. So, as I say, we rule out crystal balls. We say this is the causal explanation for the success of the predictor goes by a kind of common cause story, not by a kind of causal effect story. So it's that there are features of me and the way I have been and the way my attitudes and values have developed, which, as they were at some past time when I took some tests, affected my results on a test, which involved decisions, but nevertheless decisions that have already been made, and which then led to the results of the test being given to the predictor, who assessed them and made a decision based on them. So something I did in the past played a role, or at least features of me in the past, maybe they just brain scans or something, didn't have to be decisions, led to two things. First, it influenced my choices, and second, it influenced the predictor. But no causal relationship between the two. It was like the case, say, of I bend a coin in a certain way to give it a bias, and then, but I don't know exactly what bias, and then I flip it a lot of times. And I base my prediction of whether the coin will land on flip number 17 on the first 16 flips. It's not that I think the first 16 flips have any causal influence. It's not that the bending changed in the course of this by the way it came up. It's rather that they give me information about the nature of the event, which also is going to affect the flip of the coin later. So this kind of causal structure, you have a common cause of things which themselves are independent at that point. So you want to specify, but you can say, well, I'm not sure that's right. Maybe the story about how the predictor worked is not right. Maybe secretly the predictor has his method of cheating, and so she's going to somehow sneak the money in there at the last minute if her prediction is wrong. But you can still ask the question. You can ask the conditional question, what would you think was the rational thing to do on the hypothesis that we have causal independence? So in all the debates about Newcomb's problem and related problems, one of the lines of thought is to say, let's try to make the example as realistic as possible. And so there's a contrast between extremely unrealistic versions of the example, which it seems hard to make sense of except with some kind of science fiction, and then examples which seem more natural. There's therefore maybe not quite so decisive. But, some people assume, let's assume the predictor is perfect. Say, what do you mean perfect? Couldn't possibly make a mistake, or something like that. No, we can't assume that. I just assume she doesn't make any mistake, or doesn't make very many mistakes. And it's best if it's only pretty probable. David Lewis argued that, the Newcomb problem may be a problem that never arises in real life, but he argues that the prisoner's dilemma in game theory, under certain very not unnatural assumptions, is a Newcomb problem. Some people choose, in the prisoner's dilemma, choose to cooperate, others choose to defect. You do better if both cooperate, worse if both defect, but defecting is dominant. So it's like the Newcomb problem in that respect. But if you know that the person you're playing the prisoner's dilemma with is very much like you, but choosing independently of you, then you can take your choice as evidence about what their choice will be. And then you have something that's very much like a Newcomb problem. But it's sort of built into the prisoner's dilemma that it's causally independent. And Lewis says, of course, you know, Newcomb's problems may be rare in the form that they come, but prisoner's dilemma is all over the place. Right? This is a common structure involved in, which raises puzzles about how people behave, but, or how they ought to behave and how they do behave. But nobody thinks there aren't plenty of situations which have the relevant features of the structure of this. So the real, I mean, the defender of the two-box solution will grant that part of the motivation for the one-box solution is a kind of implicit magical thinking, as to put it tendentiously. It's that you tend to build causal assumptions into robust correlations. And, you know, you say, well, let's just, you would be making a mistake if you did that, let's stipulate that. Then is it still a reason to go by the epistemic connections, not by the causal connections? Now, the further thing is, I mean, there's a further feature of this essential to it having the problematic features of Newcomb's problem, and that is that there's something less than perfectly transparent about rational choice. You can be in a situation where you learn something about yourself, about what you were. You don't make yourself into a certain kind of person, but you learn something about the kind of person you are by what you choose. But that's a familiar feature of rational action that's not perfect, right? It's not perfectly rational. So you say, what would you do if there were an emergency and you had to rush into a burning building to save a child at great risk to your life? Are you the kind of person who could do that? And I say, well, you know, I've really never been faced with a hard choice that demanded physical courage of some kind. I don't know how courageous I am. But if it were to happen, I'd find out. Right? So I could say, and I would partly be influenced by what it would tell me about that, because I would like to be that kind of person. And that's more Newcomb problem kind of thinking, right? Just thinking, well, I want to find out if I yesterday was a courageous person where I didn't get tested. And I may find that out partly by being courageous today. But in those kinds of situations, there's a mix of determining yourself, making yourself be a certain way, and discovering that you are that way. And Newcomb's problem is an attempt to bring out a way in which a choice can be purely revelatory of something over which you have no control. And there's tension in our ways of thinking about action, which the problem brings out. And that's what's artificial about the case is partly trying to make it a pure case where you separate what you cause or bring about by action and what you reveal to yourself about action. So the epistemic and the practical mix in real life, but we're trying to separate them here in a way which perhaps makes it artificial in that way.
Hi. My question is about the last problem you raised about determinism. And I thought that this problem could also concern the notion of similarity, because there is a clear tension, I think, between accepting determinism and the requirement of similarity between words for a counterfactual to be true. Mm-hmm. Because if in the possible world, the change that we require for having the antecedent true imply a change of the whole past chain, we cannot really say that is the most, that is similar. Yeah. And I think that also the notion of small miracle by Lewis maybe is not, it still implies quite a big change that maybe is not so in balance with the idea of similarity between worlds. So I'd like to know what you think about it.
Good. Okay, so the first thing is, I mean, it's true that the tensions, there's always a case when some theoretical apparatus gives rise to certain problems. I often feel, yes, those are really hard problems, and it's a benefit of my theory that it raises them. But another way of thinking about it is, these problems arise from your theory, and they wouldn't arise if we had some other theory. So it is a possibility that the tensions that Lewis brings out between counterfactual supposition and the idea of altering the world in some respect, that's the source of the problem. But then one wants to look at what the alternative is, because Lewis makes a lot of very specific assumptions about similarity of worlds, which, or then you could alter various things, but still think in the same way. But the general abstract idea of closeness, minimal difference, and so on, which just absent any particular more substantive account of that, seems very neutral in some respects. So if the problem arises from this very neutral framework of semantics for counterfactuals, then it's much harder to see what the alternative would be. Now, I think there are moves one wants to make and presuppositions of the puzzle about determinism, which may be questioned. And one in particular, I think, is, if you think in the kind of Lewis way, it's important that these worlds be worlds. They're complete, total characterizations of reality. I think it's much more natural to think of counterfactual situations as perhaps fairly coarse-grained partition of the space of possibilities. And when we say we want to hold the past absolutely fixed, we may hold it fixed on a coarse-grained level. And so one, in particular, if you want to look at a statistical mechanics example of the branching kind of structure, we say we have a macro state partition, and we ignore the differences between microstates within some, say, set of particles in motion or something. Ignore the local micro differences and then we say we hold fixed the macro state all the way back, but we don't hold the microstates fixed. And so we can have little changes in the world all the way. This is somebody like, people have argued that you can get around Lewis's assumption that the past has to remain fixed in this way. So if the microstates were different but the macrostates were the same, you'd still get some divergences in later macro states. So one of the ways is to try to reduce the tension is to think a little bit about coarser partitioning of possibilities. And the other is to think about that we're not going to get every antecedent, every potential antecedent being appropriate. So I want to say our logic has to say, take any proposition and we can suppose what if it were true. But it's only if you focus on narrower range of actions, you get of propositions saying, well, we don't even know what to do with disjunctive antecedents or something like that, but we do know what to do with action statements or something like that. Then you may get a partial theory of the kind that has. But still, they could say, no, I want a totally different way to think about counterfactuals. And, I'm going to say, well, I want to see that too, but I don't know what it is.
in your theory of counterfactuals, you have the possibility that counterfactuals are neither true nor false.
Right.
And what does this tell us about the notion of counterfactual dependence? I mean, in a sense, we think as counterfactual dependence as something that is in the world, or isn't.
Yeah.
But then the examples that, some of the examples that you give, like the Bizet and Verdi case, these seem to have to do more with our description of the world.
Right.
I mean, the fact that they do not have they're not true or false. Do you think that these features, that the selection function is partial, tells us something about the notion of counterfactual dependence, or it always concerns the way we describe facts?
Good. Yes, I think it does tell you something, and I think in particular, if one looks at examples, there are two very different sources of truth value gaps with conditionals. So in some cases, I want to say, you have chosen an inappropriate antecedent. Your antecedent is too unspecific. And that's, as you were saying, like the Bizet Verdi, like the disjunctive cases that raise problems. So in particular, as people have emphasized, even under the assumption of determinism, say that coin flips are determined, we don't get a truth value for if I had flipped the coin, it would have landed heads. Because the idea is if I had flipped the coin, I would have flipped it in a very specific way. Which way? I didn't say. Right? And it's not part of my assumption that I would say. So if you ask the question, if you had flipped the coin, which particular way of flipping it with exactly what force would you have done? And you say, that question just doesn't make sense, right? I mean, we're not concerned with that. So one kind of case of indeterminacy or lack of truth value of counterfactuals arises from using inappropriate antecedents, and it's a major task to say what counts as appropriate in a given context, but it's still there. Another, yet there's still a separate source, and that arises from chance. So you say, even if it were a genuine chance event, the flip of the coin, then even if I specified in as much detail as one could exactly how I would have flipped it, there would have been various quantum events that determined whether it landed heads or tails. I mean, there are these people, who amateur magicians or professional magicians who are have the skill of being able to flip a technically fair coin in such a way as to determine how it comes out. But for most of us, flipping it in the most specific way we could describe would still leave some chance left. So I want to say, even in a case where an antecedent is appropriate for the context, it may be a context where chance is involved. And so the most you can say is, if I had flipped the coin, there would have been a 50% chance that it landed heads. And causal independence is still involved very much in the chance case. So if I say, if there two ways to flip the coin, but it doesn't matter. If I'd flipped it this way, it would have been a 50-50 chance, and if I flipped it that way, there would have been a 50-50 chance. Then it's the flipping, the way of flipping is independent of the result. And similarly, if I say, well, if let's suppose take the kind of case Sidney Morgenbesser talked about, where you say, I'm asked whether I want to take a bet on a flip of a coin. I reject the bet, but the offer of the bet I had was I could bet on heads. He said, do you want to bet on heads? And I say, no, I don't. They flipped the coin, it came up heads. And I said, if I bet, I would have won. Say, well, but if you'd bet, things would have been different. Say, well, no, the coin flip was independent of whether I bet or not. Now, maybe it wasn't. Maybe the guy would have made it come up tails if I'd bet heads. But under a normal course of events, where it's an ordinary coin flip, which maybe would have taken place whether I bet or not, somebody else was bet on it, but then you can say if I had bet on the coin, it would have landed. If I had bet on the coin, I would have won. Now, I could say, well, there was a 50-50 chance of the coin landing heads. If I had accepted the bet, there still would have been a 50-50 chance. So the chance was causally independent. And that's when Dorothy Edgington uses these examples of counterfactuals which are probabilistic, she's using the notion of causal independence in the following way. I mean, he said, again, the example that the plane crash example we talked about, 85% of the people were killed. And if she had made the plane, she would have been one of the people with an 85% chance of being killed. So the chances of dying in the plane crash would have been the same for all the people on the plane if she had been one of them. So this is an assumption of causal independence which lies behind the judgment about a probabilistic. So in the case where the explanation for the indeterminacy is in the indeterminacy of the antecedent, we haven't been specific enough. You don't get, that's more like vagueness. We don't get probabilities. But we do get probabilities in the case where chance is playing a role as well as a sequence of events, some of which are causally independent of others. So that's, I think that's the way in which I think it does help to bring out the issues about indeterminacy.
Yes. Just out of curiosity, in the end you speak of this notion of backtracking counterfactual.
Of what?
Backtracking counterfactual.
Oh, yes, right.
Yeah. Do you think that there are also backtracking indicative conditionals? That is, consider Peter case we discussed yesterday, the case of Pete the gambler, you know.
Uh-huh.
Okay. In a way, well, you can consider a subjunctive version of some of the conditional involved there, a variant like if Pete had played, that would be because he knew he would win.
Yeah.
Okay, something like that. Okay. From which you can infer that if Peter played, he would win or he would have won. Okay, because knowledge is factive and so on. Now, and you can also think of the indicative conditional. If Pete plays, he win. As uttered by Zach, by one of the informer who know that Pete knows everything about the hands, you know, as kind of backtracking indicative conditional. But that's maybe kind of a fantasy.
Good. So I think the contrast between the backtracking and the forward-looking counterfactuals is very, it's very clear one gets a distinction where sometimes one may be true and the other false. In the purely indicative case, I think the line between forward and backward is much less clear, because the kind of forward, the sort of temporal structure of events is not involved in the epistemic relations between events. So there is some constraint on some views that you can't really know things about the future, whereas you can know certain things about the past. But what you're holding fixed in the epistemic case is your knowledge. And your knowledge may tell you something about the past directly. You don't need a backtracking special interpretation for that. So if as kind of the kind of example you're talking about, if I know that Pete sometimes has an accomplice who will help him cheat and sometimes doesn't, and he doesn't play when he doesn't. And so what I know is that Pete has decided to play, and so therefore I know that he must have arranged to cheat, and that's a past tense inference about the past, but it's a purely epistemic one, so it doesn't give rise to a different conditional. But if you're trying to explain the fact, you might say Pete wouldn't be playing if he hadn't arranged to cheat, as part of your explanation for why you know he is going to cheat, because he has chosen to play. But that's a counterfactual again, or not, and so backtracking counterfactuals are going to play a role in epistemic reasoning, as are forward-looking counterfactuals. But whether there's a distinctive contrast in the purely epistemic cases seems to me not so clear. Yeah.
So I was wondering something about the analysis of the similarity relation based on laws of
analysis of the
similarity relation between words based on, let's say, laws of nature or miracles. Because suppose I'm juggling a vase, and someone comes along and tells me, look, if you drop the vase would have broken. This counterfactual seems to be true independently of, let's say, whether determinism or indeterminism is true, but it seems to be true just because our inductive evidence tells us that when a fragile thing falls down, then it breaks. On the other hand, suppose we are in a, say, lab and we are testing electrons, and I say, if I had fired the electron, it would have taken root B instead of root A. And if indeterminism is true, or, I mean, in this kind of setting, indeterminism or determinism matters to the truth of the counterfactual. So it seems to me that the kind of similarity relation that becomes relevant in order to evaluate counterfactual depends on the communicative context in which counterfactual are asserted, because sometimes laws of nature you need to take into account laws of nature in order to determine whether the counterfactual has a certain truth value. But most of the time you don't need to evoke metaphysical pictures such as, let's say, determinism or indeterminism in order to say, look, what you said is true or false, or look, you said something false. So to what extent do you think the, let's say, metaphysics of laws of nature and is relevant?
Good. So even on Lewis's view or anyone's, even though Lewis wants to say laws of nature get broken in counterfactual worlds, They got to be broken in little ways, which means, in effect, I mean, again, for Lewis, a law is just a global description. But if you think of a law as something that applies locally in some way, then you can say you do assume that the laws continue to hold even under counterfactual circumstances, in a sense that adding an exception for the antecedent, it's still going to remain true. Now, of course, the laws can be indeterministic on certain theories or certain assumptions, and that gives you a little bit more flexibility in some ways, in that it could be that the very same laws hold, but different things happened, even in the local situation in question. But either way, you're going to get causal independence playing a central role in that. Even under, we talk about, say, sending a laboratory quantum mechanical experiment or something like that when you do some putting a particle through some mirror or something like that. You could say, well, if I had done it a minute later in exactly the same condition, that is, I repeat the test conditions perfectly, it still might have occurred differently. Right? But you also say that if I sent two particles and in different directions, and I say if I'd not done this one, that one would have been the same. Well, then you have special quantum mechanical problems where maybe that's not right. So the whole idea of causal independence is problematic in its application to some kind of situations in scientific things. That gives rise to controversy of interpretation of the scientific theory. So one hypothesis is that there are lots we assume about the causal structure, and it works well on the macro level, those assumptions. And the world answers to them, so they're true in some. We should be realist about it in a sense, but they're not fundamental, and that maybe those very structures break down at a different level. So I think wants to be open to the possibility that some of the robust intuitions we have about causal structure and counterfactual dependence and independence are going to be called into question by a scientific theory.
Any other question? I maybe ask a question about the relation between determinism and causal independence, because
Difference between?
the relation between, not the difference, the relation between determinism and causal independence.
Right, yeah.
Because it seems quite evident that if we consider two events locally, we can consider them to be causally completely independent one of the other.
Uh-huh.
But if we start to amplify our considerations, even the two events which are considered locally independent may have some, or either a common cause or some connection, some causal connection in the past, in the very past, even centuries, going back to predecessors and something like that. So, if we consider this kind of situation, can we really maintain that determinism is compatible with causal independence?
Good. So, of course, it could be causal chains intuitively separate and then come back together in some cases. So even if it's clear that there's no sort of conspiratorial story of how it is that Alice happened to drop the flower pot just when Bert was passing by, one could say, nevertheless, remember back 40 years ago when Alice actually met Bert and they talked to each other and were influenced by each other in certain respects. And that played some role in the rest of their lives, which led to this event. So then that's a kind of case where, I mean, I think one still wants to talk about causal independence, and that it was a coincidence that an earlier event set off a sequence of events in two different ways that led back together again in this way. But I think it's right to raise a question about how to deal with the difference, or how to explain the difference between a story for a coincidence, using coincidence in the neutral sense of two events coming together in some way, an explanation that is really no explanation at all for why this and that happened at the same time, and an explanation which does explain why these two things happened at the same time. And that's an interesting question about the nature of explanation. But you know, to say why did the flower pot drop just at this moment? The intuitive answer is, in the case I'm thinking of, it just was a coincidence. There's no further story to be told. When we say, well, wait a minute, we can tell a completely good story of exactly why she did what she did at the time, and a perfectly good story of why he was there just at that time, and put those two stories together, and you have an explanation for why they happened at once. Right? You say, yeah, but that doesn't answer my puzzlement about why they happened at the same time. Right? And I think the reason there is puzzlement is because, and then again, this is an epistemological point, but when there are alternative hypotheses in play which come to mind and one wants to rule out, that makes coincidence seem in need of explanation. And the explanation might be, no, there isn't any explanation. So it's the same way, if you flip the coin 20 times, and it lands heads, tails, heads, tails, heads, tails, heads, tails. I say, why did it do that for 20 times? That was enormously improbable. And I say, yeah, every sequence of 20 flips of a coin is enormously improbable. Why is this one any worse than any other? And the answer is because normally when things go in sequence, heads, tails, heads, tails, heads, tails, there's some explanation for why they're not independent of each other. But, you know, sometimes there isn't. And you can say, no, it was just luck. It was just chance. Or 20 heads in a row, or whatever, same thing. So I think one does want a good account for one's epistemology and one's metaphysics of what the difference is between a coincidence and an explainable convergence, and why it counts as a surprising coincidence, even if the right explanation is that's just the way it is. So, but as I say, you could have a common cause which really was still just a coincidence of the kind you're suggesting.
Any other question? Probably it was a difficult topic. We will think about it tonight, and maybe tomorrow we will raise some other questions. Thank you very much.
Okay, thank you. Thank you.